everyone, I wanted to make a couple short videos for you guys since I wasn't able to do online office hours this week. I wanted to make sure that you guys had an opportunity to review the material for Chapter 1. So the very first thing that we started talking about in Chapter 1 was the classification of matter. So there are three phases of matter: solids, liquids, and gases. As you guys already know, solids, in a solid, the particles are close together, like I've drawn here. There's a definite volume and a definite shape for solids. Liquids, the particles are also close together. There's a definite volume, but a liquid would take on its shape of a container. Gases, there's a lot of separation in between the particles. They expand to the volume of a container. They take on a shape of a container. The next designation of matter that we talked about was between pure substances and mixtures. We said that a pure substance could either be an element or it could be a compound. The major difference here being elements only have one type of atom, compounds have more than one kind of atom. So for elements, we can either have atoms of an element or we can have molecules of an element. So atoms of an element would be a single element. Molecules of an element would be two or more of those atoms of that element bonded together. So some examples that we talked about in class: for atoms, we talked about helium as a particular example, and then for molecules, we talked about N2 and O2. For compounds, some examples that we had were water. Another compound that we talked about in class was hydrogen peroxide. So any sort of bonding of one or more different kinds of atoms is what a compound is. For our for our distinction of mixtures, we talked about homogeneous mixtures. Those are evenly mixed. And we talked about heterogeneous mixtures, which are not evenly mixed. So some examples here in class, we talked about corn syrup, which is a mixture of fructose and glucose, and for a heterogeneous mixture, we talked about vinaigrette, which is a mixture of oil and water. Those don't mix evenly together, so that would be a heterogeneous mixture. We also talked about, in thinking about matter, physical and chemical properties, as well as physical and chemical changes. So physical and chemical properties, physical properties are going to be properties like melting point, boiling point. Those properties that don't require any sort of physical, or that don't require any sort of change in the identity of that substance. Chemical properties, on the other hand, are going to have a change in the substance, and is going to be interacting with some other substance. So something like corrosiveness, toxicity, acidity, or basicity are examples of physical and chemical, or examples of chemical properties. Some of the things that we talked about in class. For a physical change, we talked about phase changes. Anytime something moves from a solid phase to a liquid phase, or from a liquid phase to a gas phase, that's going to be a physical change, and there's not going to be any change in properties, in physical properties. So an example would be, another example might be dissolving sugar in water. And then for chemical changes, we talked about how a chemical change is going to result in the change in connectivity of atoms. And so an example that we gave was in class was iron rusting. So there's an introduction of oxygen into iron for it to rust. So some of the ways that you guys might have to apply some of these concepts would be in the following. Let me move this over here. So these are some questions from a previous exam. And there's examples as well in the book that you should look at as well as your homework. So the first one says, classify the following as an element, compound, mixture, and justify your classifications. So we have sodium chloride. Sodium chloride is a compound. Seawater. So seawater is a mixture of water and salt and some other things. So we have sodium chloride as a compound, seawater as a mixture. Sugar is a compound. It's a pure substance, so it's a compound. And ice. Ice is just water. Ice has two, since it's water, it has two different atoms in it, so it's a compound as well. The next one says, each circle represents an atom. Which of the following boxes contains an element, a compound, and a mixture? If we look at A here, we have a mixture, and I would say that this would be a homogeneous mixture because this is evenly mixed. But we have this right here, which is a compound because there's two different kinds of atoms. And then here we have an element. So A is a mixture of a compound and an element. B is a pure substance. B has two different kinds of atoms bonded together, so this is going to be a compound. And then C, we have two different, two of the same kinds of atoms bonded together, so this is going to be an element. So again, A is a mixture of a compound and an element, B is a compound, and then C is an element. Let's look at this image here. So this is representing a homogeneous mixture of molecules of an element, two different kinds of molecules of an element. That's how I would describe this. So you guys should also have some sort of practical application of this as well. So how would you classify a cappuccino with foam? So a cappuccino is evenly mixed, but if you have foam on top, then that foam is not mixed with the coffee and milk part below it. So this is going to be a heterogeneous mixture. So let's look at how you might be asked to look at chemical and physical changes. So the diagram A here is a compound made up of two elements. It's represented by the green and red spheres. And it's in the liquid state. And so we want to describe what's happened in B, C, and D, whether or not they're a physical change or a chemical change. So if we look at B here, we see that the connectivity of the atoms in A has changed. So the two red atoms are bonded together and the two green atoms are bonded together. And so this is going to represent a chemical change, and this would be particles in the gas state. For C, we have red atoms and green atoms that are no longer bonded to any other kind of atom, and so this is different from A. So this also is a chemical change, also in the gas state. And then D here, we've gone from a solid to a gas, or a liquid to a gas. So we have red atoms and green atoms bonded together just like in A. Let's look at this question here. The following image represents what kind of change? Well, this is going to be a chemical change because you can see the connectivity in the first box has changed in the second box. We have in the first box this light gray atom bonded to a dark gray atom, and then two light gray atoms bonded together and two dark gray atoms bonded together. Okay, so this is sort of the recap for how we classify matter. I'm going to do a video next on the prefixes and dimensional analysis, as well as sig figs.